reason we need to make sure we revisit these basic things in trigs is that when we start to build on it, so remember last time we were supposed to do things like cosine rule and sine rule, and essentially it doesn't make sense to move into advanced topics unless we fully comprehend all the little basic things. So part of doing multiple choice is knowing all these little basic things and being able to apply quickly. I just want to show you all some of the multiple choice questions, like how they usually come, and then we'll get into the trigonometry itself, so you'll get an idea as to what trigonometry looks like on the test paper and what you need to learn in order to understand it. All right, these are some of those multiple choice questions. So trigonometry is not just basic find the length of this side or find the size of that angle. It is also things like angles of elevation and angles of depression. Essential things for trigonometry would be knowing the theory, but also using it practically and using your calculator effectively. So we're going to get started, like I said, with the basics of trigonometry. All right. Well, our objectives for today, right? We're going to be going over the right angle triangle and its properties, right? So all those little basic baby things that you would know is just to make sure to rebuild that foundation and make sure that everybody's on the same page with it, right? Pythagoras theorem and its applications, which we would have touched on, and then we're going to talk about trigonometric ratios of sine, cosine, and tangent. Then obviously you want to know how to use your calculator properly, so you're going to learn about getting the trigonometric values of angles using your calculator, and then how you would use your calculator to get the values, all right, involved with particular trig ratios. And from there, once we know how to do those things, we should be able to apply trigonometric ratios to solve a variety of problems that we may meet. Right? Obviously, you're going to hear triangle a lot when dealing with trigs. You're going to be learning about the right angle triangle, so obviously you'll hear that. Angle, side, these are things that you hear a lot with ratios in particular. And Pythagoras theorem, everybody's favorite. We hear the word hypotenuse, adjacent and opposite when we deal with trig ratios, but we hear hypotenuse every time we start dealing with Pythagoras theorem. Alright, and right angle triangles as a matter of fact. Then sine, cosine, tangent, which would be our three trig ratios. Theta, which is that Greek symbol that looks like a zero with a line through it. Theta is not the only Greek letter we usually use in math. We also use alpha, we use theta. Sometimes you might find gamma here and there. They may use epsilon, but epsilon is more associated with sets. Alright, but just so you know, theta is the one that I use mainly in this document, so that's why theta is here. Inverse, because if a function exists, it should have an inverse function, alright? And trigonometric values and trigonometric ratios, okay? So keywords that we need to know and be familiar with and understand what we mean by these particular terms when we are referring to them, because understanding what they represent or what they are will help us with, building a more sound foundation with mathematical jargon, for instance, because a lot of times I've had students who don't know the proper terms for things and they kind of just refer to it loosely as, something in more layman's terms. So you want to be somebody who is quite fluent with math as well. So we need to know all those basic things, right? Just like with a foreign language, you'll learn your basic vocab. In math, we have vocab that we need to know too. So that's why it's good to know specific words associated with a particular topic. All right. Now, when we talk about the right angle triangle, the right angle triangle doesn't always look like this one per se. Sometimes they will change the orientation a little bit. So sometimes you'll notice it where the right angle, like in this one, or even this. Although sometimes, visually, when diagrams aren't necessarily drawn to scale, it's a little difficult to identify a right angle triangle. There are a few things that are very characteristic of a right angle triangle. which allows us to distinguish the right angle triangle from any random triangle that they may put in an exam. So for instance, when we talk about the right angle triangle, we need to know that the key thing that makes a right angle triangle is that it consists of a right angle. And we know that the right angle is an angle of magnitude 90 degrees. Alright? So once we notice that we have a right angle in this triangle, this tells us that this is a right angle triangle. And we know that they usually show us that right angle in the triangle with this little square. And it will have typical triangle properties as well. So that's why all those basic things, you still need to know that it is in fact going to hold true. Although we have this one particular angle of 90 degrees, it doesn't mean that the other two could be anything it wants to be. The triangle still will have a sum of interior angles that is 180 degrees. Alright, so the typical geometry rule that the triangle has the sum of interior angles as 180, that still holds. As well as it must still have 3 sides in order to be called a triangle. And it will have 3 interior angles as well. So these 3 fundamental things still hold. Right angle triangle or not, it's still a triangle, and it still will hold with these 3 main properties. Tell me, what do you know about exterior angle?
Well, it's the angles on the outside of the triangle, and all of them when added together make up 360 degrees.
Very good. Alright, so I have a question for you. If we are looking at the exterior angles of this right angle triangle, alright, so the purple one here with the little yellow right angle, where do you think the exterior angles would form? You can tell me?
Right, I only see the 2 lines A and C on the triangle.
Just
like you were saying.
Just now. Looking at this one here, seeing the pointer?
Oh.
Yeah, this one.
Yeah, I see it.
Right.
What was the question?
Alright, so where would our exterior angles form in this particular triangle?
The exterior angle.
Mm-hmm.
The other side, the 90 angle.
Okay, so that's just one. So you want to go ahead and draw in where that exterior angle would form for me?
Okay. Maybe here.
Yeah, essentially, yeah. That's a good idea. Alright, now if I wanted to draw in the angles, I'll draw the lines to show you where the angles reside. Alright? So if I wanted to form an exterior angle, like you said, up here, we'll draw a line extending upward from the right angle. One of those exterior angles will form on the same straight line with the 90 degree. Now, it's quite interesting that the exterior angle, as long as it is on the outside of your triangle, and in this case, once it forms that straight line with the interior angle, it is the exterior angle. So it could form upward, or it could also form coming across here. But we're focusing, like I said, I'll focus on where you identify the exterior angles. Right? So the next one, you said the exterior angle would form on the side here. So if we were to draw the exterior angle, this angle down here, this is where it would form. Alright? So this is our angle, and our exterior angle. There we go. Alright, let me just highlight this one as well. Okay, let's form our final exterior angle. Alright, our final exterior angle. Basically, once we know how to identify where the exterior angles are, we know this theorem about the exterior angles. Okay, that the sum of the exterior angles is 360 degrees. So it's just information that we need to understand, because when we deal with polygons in particular, questions don't just come on interior angles, they also come on exterior angles to test your knowledge to see, well, okay, do you understand what is this exterior angle concept?